Ferrari has just rocked the F1 world by secretly testing a game-changing 2026 component during the Abu Dhabi weekend, leaving rivals scrambling to catch up. The mule car incorporated an advanced double pushrod suspension and cutting-edge active aerodynamics, giving Ferrari a potential leap in performance before the season even starts. The twist: Charles Leclerc and Lewis Hamilton were both behind the wheel, pushing the car to its absolute limits and generating telemetry and feedback that could redefine Ferrari's strategy for 2026. And the fallout: rival teams are frantically analyzing leaked footage and telemetry, questioning whether Ferrari's bold move gives them a decisive advantage or if it could backfire under pressure. Subscribe now, you don't want to miss a single revelation, as Ferrari's secret 2026 project could reshape the entire Formula One hierarchy. The Abu Dhabi weekend took an unexpected turn when Ferrari secretly ran a mule car equipped with a key 2026 component, catching rival teams completely off guard. The secret test focused on a revolutionary double pushrod suspension and advanced active aerodynamic elements, indicating Ferrari's ambitious strategy to gain an early performance edge before the 2026 season even begins. The paddock buzzed with speculation as teams scrambled to understand what Ferrari had discovered in their clandestine testing sessions. Telemetry data captured during the test provided engineers with detailed insights into the car's dynamic behavior. Sensors recorded suspension travel, ride height, tire load, and aerodynamic efficiency throughout high-speed corners and braking zones. This allowed Ferrari to quantify the exact performance gains achieved by the new components and evaluate how the modifications improve stability, cornering speed, and overall lap performance. Drivers Charles Leclerc and Lewis Hamilton were instrumental in pushing the mule car to its limits. Their experience allowed them to test the component under extreme conditions, simulating aggressive cornering, acceleration, and braking scenarios. Feedback from the drivers provided valuable qualitative data, complementing the telemetry readings and enabling engineers to adjust the suspension geometry and aerodynamic settings in real time to optimize performance. High-speed video captured every moment of the test, offering a visual verification of the telemetry and driver feedback. Frame-by-frame analysis showed how the suspension absorbed curb impacts while maintaining tire contact and aerodynamic balance. Engineers could see how the active front wing adapted dynamically, improving downforce without compromising straight-line speed. This combination of visual and numerical data ensured that Ferrari could validate performance improvements before committing to full-scale 2026 implementation. Mechanical simulations ran alongside the real-world tests, modeling tire loading, suspension kinematics, and aerodynamic flow across different track conditions. These simulations allowed Ferrari to explore extreme scenarios that could not safely be tested on track, ensuring that the new components would maintain performance and reliability under a wide range of racing conditions. The combination of on-track and virtual testing gave Ferrari a comprehensive understanding of the component's potential. The paddock reaction to Ferrari's secretive program was immediate and intense. Rival teams analyzed leaked images, telemetry hints, and insider reports, attempting to deduce the technical advantage. Analysts debated whether Ferrari's early innovation would translate into a decisive 2026 advantage or encounter regulatory or reliability constraints. The secrecy and audacity of the test amplified the intrigue surrounding Ferrari's strategy. Finally, Ferrari's Abu Dhabi test highlights the evolving nature of Formula One development. By integrating telemetry, driver feedback, high-speed video, and mechanical simulations, the team gained a multi-dimensional understanding of their new 2026 components. This approach exemplifies how strategic secrecy, technological innovation, and precise engineering can provide a competitive edge, potentially reshaping the hierarchy before the season even begins. Ferrari's secret testing during the Abu Dhabi weekend generated an extensive set of raw data that engineers immediately began analyzing. Every sensor on the mule car collected telemetry on suspension travel, ride height, tire load, and aerodynamic forces. This allowed the team to see exactly how the new double pushrod suspension and active aerodynamic components performed under real-world racing conditions, giving Ferrari an early advantage in optimizing the 2026 car. Mechanical simulations complemented the physical tests, allowing Ferrari to evaluate how components behaved under extreme scenarios without risking the mule car. The simulations modeled tire loads, suspension kinematics, and airflow across the car, providing predictive insights into cornering efficiency, downforce generation, and potential stress points. This approach ensured that theoretical gains could be validated before committing to full-scale implementation. High-speed video footage captured every aspect of the mule car's performance. Frame-by-frame analysis allowed engineers to visualize the dynamic interaction between the suspension and aerodynamics, confirming telemetry readings. They could observe how the suspension absorbed curb impacts while maintaining optimal tire contact, and how the active front wing adjusted to maximize downforce without compromising speed, ensuring the components delivered practical performance gains. Driver feedback provided another critical layer of raw data. Charles Leclerc and Lewis Hamilton reported on steering feel, car balance, and overall handling under extreme conditions. Their subjective impressions were correlated with telemetry and video data to refine suspension damping, wing angles, and chassis settings. This combination of human feedback and technical data ensured a holistic understanding of the mule car's performance. Environmental conditions during testing were meticulously recorded. Track temperature, wind speed, and humidity were monitored to evaluate how these factors influenced the new component's performance. Ferrari engineers could simulate varying race conditions, ensuring that the 2026 upgrades would perform consistently across different circuits and weather scenarios, a critical factor for pre-season advantage. The integration of telemetry, simulations, video, and driver feedback produced a robust, multi-dimensional dataset. Engineers could analyze lap time gains, cornering stability, and aerodynamic efficiency to guide iterative improvements. This comprehensive approach allowed Ferrari to refine components rapidly and with confidence, maximizing the potential competitive edge for the upcoming season. Finally, the paddock reaction to Ferrari's secret program was immediate and intense. Rival teams, media, and analysts attempted to reverse engineer the data and anticipate the impact on the 2026 season. The audacity and secrecy of the test underscored how critical innovation and early data acquisition are in modern Formula One. Ferrari's approach demonstrates that success now relies not only on speed on track, but on strategic engineering and intelligent pre-season development. In Formula One, technical innovation is often the difference between winning and losing, and Ferrari's secret Abu Dhabi test exemplifies this principle. The mule car, equipped with a 2026 double pushrod suspension and advanced active aerodynamics, provided engineers with a wealth of raw data. Sensors captured every millisecond of ride height variation, suspension travel, tire load, and aerodynamic response, allowing a complete picture of the component's real-world behavior. Telemetry analysis revealed that the new suspension configuration improved tire load distribution during high-speed cornering. Engineers could see how the system absorbed curb impacts while maintaining optimal contact, reducing understeer and oversteer. The data confirmed measurable handling advantages, demonstrating that the component offered both performance and stability gains critical for a competitive 2026 car. Mechanical simulations were used to complement on-track data. Using computational fluid dynamics and structural analysis, engineers evaluated how the suspension and active aero components interacted with airflow, tire loading, and chassis dynamics. The simulations predicted performance under extreme track conditions, helping engineers optimize geometry and damping parameters for maximum efficiency and durability. High-speed video analysis corroborated the telemetry and simulation results. Cameras captured the mule car from multiple angles, allowing frame-by-frame verification of suspension performance and aerodynamic adjustments. Engineers observed how the active front wing dynamically modified downforce to improve cornering speed without compromising straight-line velocity, ensuring that theoretical gains translated into practical advantages. Driver feedback was an essential component of the technical assessment. Charles Leclerc and Lewis Hamilton provided real-time impressions of steering feel, balance, and responsiveness. Their subjective input was compared with telemetry and video analysis, allowing engineers to fine-tune the suspension and aero setup. This integration of human feedback with data ensured that the 2026 upgrade would be both effective and intuitive for the drivers. Environmental monitoring was conducted throughout the Abu Dhabi testing sessions. Track temperature, wind, and humidity were logged to understand their influence on the new components. By analyzing performance under varying conditions, Ferrari ensured that the suspension and aero systems would maintain consistent efficiency and reliability across different circuits and climates in the 2026 season. Finally, Ferrari's comprehensive technical approach underscores the modern F1 development philosophy. By combining telemetry, simulations, video, driver feedback, and environmental analysis, the team gained a complete understanding of the 2026 component's performance. This multi-layered evaluation allows Ferrari to enter the next season with a potentially decisive advantage, showcasing how innovation, secrecy, and engineering precision are central to Formula One's success.